Hello, folks, and welcome to another episode of Wayne's World of Science and Technology. I started this channel because I wanted to talk about all the neat stuff that's going on in science, and instead we have what's going on in Ukraine. And, I found myself in a position where I know some things that aren't general knowledge. I mean, they're not secret, they're perfectly public. It's just people don't know it because it's an oddball area of subjects study. Sorry, I'll learn how to talk this week, I promise. And so I posted on Twitter, and a bunch of people responded. And I decided I should cut a video to explain it in just a little bit more detail, and also so I could address some of the questions I got. So, here we go. Oh, and by the way, I am not a subject matter expert. I'm a jack of all trades. I'm interested in everything. So, yeah, there's a lot of stuff here I don't know, but the stuff I do know, I'm pretty certain because I got it from experts. And, these are people who have a track record in the technology industry. So, Russia is dead competitively. Copyright me 2022 under Creative Commons Attribution 4.0 International License. Yep, I'm happy to share. You can reuse, remix under any circumstance, including commercially, as long as you follow the license. And there is a link to the license in the YouTube description. And you'll hear me saying link to in the description a few times here. What you're seeing on screen right now is a silicon wafer, and it's the basis of all modern technology. Without the ability to produce printed wafers, you cannot make microchips, and microchips are, they're in everything. And I mean literally everything. It's not just your phone, it's not just your computer. Do you have a Keurig? Yeah, it's got chips in it. You have a microwave? It's got chips in it. You have a toaster? It has chips in it. If a refrigerator is less than 5 years old, it's got chips in it. My toothbrush has chips in it, for God's sakes. I mean, they're everywhere. People don't realize it because they're hidden behind things. They're just a part of what makes things work. They're a natural part of our environment now. We don't notice them. We don't think about them. And why would we? We don't need to think about the fact that there's a microchip in our toothbrush. We just need to use the toothbrush and get our teeth clean. The rest of it, hey, that's for the engineers, right? So, Russia is dead competitively. What do I mean? Simple. Because microchips are the basis of today's society. That's why they're dead competitively. CNBC recently put out an excellent video in a company called ASML, which actually led to my tweet because, before that, I didn't have anything I could put forward and say, okay, here, folks, watch this video, you'll understand. And the video is excellent. There is a link in the description. Why is ASML important? Because ASML is at the bleeding edge of the technology sphere. When I say they're at the bleeding edge, they're doing stuff that nobody else can touch. We aren't just talking, they're building the machinery that iPhones and Samsung Galaxies are built on. We're talking that they're building the machinery that supercomputers are built on. We're talking microprocessors that sell for the price of a Mercedes. Yeah. That's the sort of machinery that is being produced by machines manufactured by ASML. And, we're talking from relatively low power, in the case of a phone, and though quite frankly, the fact that your current iPhone 13 has more computing power than existed in the entire world in the early 60s. Anyway, the high level ones, they're used for things like black hole collisions and weather forecasting. expensive stuff. ASML provides the machines that make all of these chips, all the advanced ones. ASML is the only company capable of producing the high-end production equipment. They've only actually produced 140 of the top-end ones. Yeah, just think of that, 140 in the entire world. Russia has none. China has none. Nor can they make them due to lack of critical infrastructure, nor can they buy them due to sanctions, which I forgot to put in there. It's one of the reasons why I'm lousy at this. Every time I do a presentation, I always spot a word I missed. Even worse, Russia never developed any indigenous chip manufacturing technology. They bought some obsolete plants, plants that are 20 years out of date, but buying isn't the same as developing. I mean, you can buy a factory, operate it, and have no idea how to make the machinery in that factory, even if you know how to maintain it. Belarus also has an obsolete plant that they bought, which is also in the 90 nanometer range, which is the same range as the Russian plant. 90 nanometers is an important number because 90 nanometers is where things start getting difficult in chip design. Or I should say in chip manufacturing. The design doesn't get any worse, but the manufacturing gets a lot worse at that point. Both Russia and China have tried to move below 90 nanometers. Russia has at least one test fab which has produced some 65 nanometer parts, and China can produce some 28 nanometer parts now. As a contrast, the top-end TSMC chips are coming in at 4 nanometers, so Samsung, and I think Intel's at 5 or something like that. It's really, we're talking the lower the number, the better. And, 20-year technology difference from 90 nanometers to the current top end. 20 years ago, 90 nanometers was the top end. Now it's considered outdated. It's extremely hard technology to develop, anything below 90 nanometers. That's why only one company has managed to do it. No, I say managed to do it. There is another company making some equipment, but it doesn't go to ASML's level. They can't do the very top end. They can do down to something like 14 nanometers. Anyway, the costs are prohibitive to develop this technology. It required support from the 3 largest chip manufacturers, Intel, Samsung, and Taiwan Semiconductor Manufacturing, for ASML to be able to do this. Each machine costs $150 million plus. 140 machines, and they're selling for $150 million plus. Now you see how they can afford to produce that low a number of machines. These things are expensive. And the newer ones for the next stage are supposed to be, even more expensive. But let's look at it right here. We've got, that's $21 billion worth of sales on those 14 machines. Just for comparison, Russia has a total gross domestic product of 1.9 trillion or 1.9 billion. So this is just about a bit more than 10% of that gross domestic product that ASML has sold in these big machines. Korea, Taiwan, the EU, and the US are the only sources for the technology used by ASML. When I say the only sources, I think Japan also supplies some of the kit, but I'm not 100% certain, and so I didn't list them there, but I'm pretty sure that they were involved too. You will notice that these countries or regions are the ones with the best universities also. Every time Russia fires a precision-guided weapon, they lose chips. Every weapon fired cannot be replaced. This may be partly why the Russians aren't using precision-guided weapons as much as expected. Now, this also affects ships, planes, and land vehicles. That T-90 tank the Russian soldiers surrendered for 10,000, it had those chips in its fire control and optics systems. And yeah, that's why Russian tank manufacturers appear to have shut down. They can probably build late Soviet gear, but nothing more modern because they can't get the chips. And oh, by the way, the sensor systems also tend to be chip based to a certain extent. So, yeah, the sensor systems are off, they're not obtainable either. The aircraft carrier Admiral Kuznetsov was supposed to get new radars, but hey, no chips. Those fancy Su 57 cell fighters, no chips. For radar, fire control, missiles, nada. They have just become white elephants. And what about all those countries buying Russian arms? Well, let's just say that India is really regretting not buying Western weaponry right now. So are a lot of countries because the deliveries have stopped dead and can't restart. Russia can't buy the parts needed to ship to export the stuff. Of course, even if they could actually afford to export it, they probably need this machinery for their own war. We may see some countries that start using Western technology to upgrade Russian equipment. Will have to. And that'll be an even worse hit to the Russian economy as they lose more of their military business. And some companies like Saab are probably going to see a lot of extra sales. And, well, France's Dassault is also going to see a lot of extra sales because you got people whose airplanes are old and they need replacement. You got people whose tanks are old and need replacement. They can't buy Russian, they can buy Russian, but Russian isn't effective in combat. They aren't going to buy Russian. Buy Russian defense industry. And one thing that everybody always says is, oh yeah, but Russia can buy microchips under the table. And the thing is, they can't really. Russia can't sneak chips through a third-party vendor. Intel, Samsung, and TSMC know what the current Russian designs look like. They all would have been asked to quote. Making minor changes to the design won't work. Computers are developed quotes and they catch stuff like this. The sanctions regime requires checks like that, as a matter of fact. And let's face it, none of these companies are going to bust sanctions. They can't afford to. In fact, I can guarantee you that all of these countries are extremely peeved at Russia. Neon is used in microchip manufacturing and Ukraine supplies 50% of it. I don't think there's a single microchip manufacturer on the planet that wants to talk to Russia right now. The inability to purchase or manufacture advanced electronics will cause a massive drop in efficiency of every part of the country, not just the armed forces. Everything that uses microprocessors in Russia now is at risk of catastrophic failure. Trains, hey, think of the signaling system going out. That's a catastrophic failure. Planes, maybe part of your navigation system goes out and you have to make an emergency landing, or maybe ground control radar is having problems seeing you and telling you where you are. And of course, automobiles. Automobiles don't tend to be quite as catastrophic unless you call having your engine quit in the middle of Siberia in minus 40 Fahrenheit or minus 40 Celsius, since it's the same weather, a walk in the park. If you call it a walk in the park, then having your car break down in the middle of Siberia is a great idea. Russia's also cut off from the software vendors who provide the tools to work at developing advanced technologies. When current licenses die, they can't be replaced. That kills all the CAD stations and anything else that works on a yearly software licensing model. And damn near all engineering software works on yearly software licensing models. That's if it doesn't work on monthly. Even worse, the software used to develop the microchips is all Western designed. Never mind that most of the CAD software is Western designed too, but hey, there are some open source CAD solutions out there that Russia could try and use. They just aren't as full featured. So all the software used to develop the microchips is Western design and subject to sanctions. How do you design a complex microchip without software? Simple. You don't. The best chips that Russia can optimistically make now are 20 years out of date. We're talking PlayStation 2 era power, old-style BlackBerry or pre-iPhone levels of power in handhelds, Pentium 4 and desktops. You remember the Pentium 4? Wish I didn't. Mind you, the tech's still useful. No technology truly dies out. It's good enough to control a toaster, or, well, for that matter, even use an old style, power an old style computer. One with limited function. But a current, single board Raspberry Pi that you can buy today for less than $50 is at least 20 times more powerful than the original BlackBerry, and the original BlackBerry cost $700 when new. Now, remember what I said about software licenses? The usual time to redesign a chip for a different fabrication plant is 6 to 12 months. Yeah, you can't just copy it over. Each specific plant, each specific type of manufacturing setup is different. And, when I say that, between companies, if you go to TSMC, all the TSMC 7 or TSMC 4 plants will be the same. But if you're going to take it from a TSMC 7 to a Samsung 7, you'll have to redesign it. And so we're talking usual time to redesign a chip is 6 to 12 months. Oh, wonder about those software licenses. Dimitri, did you pay our software license? Yeah. Time to ramp up production after you've got it designed is usually 3 to 6 months. Now, I said 6 to 12 months. 6 is on the optimistic end. 12 is what I would regard as normal, okay? It could be longer. 3 to 6 months, 3 is the optimistic end. 6 is what you'd normally get. Usually be talking a bit longer. Because, let's face it, things don't go perfectly. It doesn't matter how good you are. There's always going to be problems. So any decision to change suppliers is going to leave the military constrained for at least that time. In other words, 18 months minimum, but probably longer. And that assumes everything goes to plan on their end and enough materials are in hand, because some of those materials to make microchips also come from the West. Oops. I don't think Vladimir was awake when he made that decision. The plants that Russia and Belarus have are extremely limited in capacity. The Chinese 28 nanometer node isn't as constrained, but it still has limits on how much it can produce. But, and here's something I forgot to put in the presentation. Remember that we're in the middle of a global semiconductor shortage? How much do you want to bet that every single one of those plants is pumping out semiconductors day and night, 24/7 right now? Every single one of which is critical to somebody. Yeah, just think. You got device manufacturer A over here, and he can't get chips, so he's not shipped there. The device manufacturer A can't ship stuff, so the trucks that would take the product from device manufacturer A to distribution plant B, well, they aren't running, so they're laying off people. Device manufacturer A is laying off people because he can't make product. Distribution warehouse B isn't getting any product in, so they're laying people off. Meantime, they aren't paying the courier companies to drive to the stores, so the courier companies are laying people off. And, well, the stores don't have anything to sell, so they're laying people off too. And, well, guess what happens to your economy? Yep. Kaboom. So Russia and its allies cannot produce their way out of this bottleneck quickly. From the time a decision is made to build a new plant to when chips roll out is usually 2 to 3 years. So, even if they can get everything switched over and get the design onto the 90 for the really, really critical stuff, or the Chinese 28 nanometer node, they're still stuck for at least 24 months, most probably 36 months or over, before they can start producing chips for anything else. And during that time, stuff is failing. And they can't buy replacements. Another issue is that Taiwan Semiconductor Manufacturing produces the most reliable wafers out of all the manufacturers, with Intel and Samsung really close behind. I have no data on Belarusian, Chinese, or Russian reliability levels. Reliability is an issue because wafers often have blemishes which may make some of the chips non-functional. The lower the node number, the worse the impacts of blemishes because the transistors written on the chips are so much smaller, so a smaller blemish can knock a chip out. Whereas before, a small blemish might have fallen on a non-active part of the chip on, say, the insulator part, instead of on one of the transistors. And but the thing is that smaller chips are faster and more efficient. And another thing about smaller chips being faster and more efficient, let's take a 4 nanometer chip. You get a 4 nanometer chip. No, 7 nanometer. That was what I looked up. 7 nanometer works out to be, I think it was 16 times denser than 90 nanometers. So this means if you have a 1 centimeter by 1 centimeter chip, a 1 centimeter squared chip on 7 nanometer, it is going to be 1 centimeter to the 16th power space, I can't add it up my head. It's going to be a hell of a lot bigger, put it that way. Sorry, I'm terrible with math. But yeah, the thing is that to put the same number of transistors on a chip, you've got to make it a lot bigger. And they just can't do it. Because the bigger they make the chip, the more the blemishes are going to hit. That's why when you hear about things, weird things like AMD all of a sudden going to chiplets. Well, yeah, of course they went to chiplets. This means that they had a smaller chip is going to take less likely to get hit. If you have one chip on a wafer, the blemish is going to hit it. A single blemish is definitely going to hit it. If you have 4 chips on a wafer, one chip will get the blemish. If you have 9 chips on the wafer, one chip gets the blemish, and you've got 8 good chips. You see where I'm going on this? The more chips you can get off that wafer, the better you are by making it smaller. If they have to squash huge numbers of transistors onto a chip to make it perform, it is really going to hurt their production levels. And I mean, they have no way around it. Effectively, Russia assumed that they'd be able to buy chips no matter what, and they didn't invest in the R&D to try and push further. Nor did they try and develop their own plants. They bought them. This lack of infrastructure will kill the Russian economy and the military. Very few mobile phones last longer than 5 years. Very few computers last longer than 5 years. My estimate is that Russia may manage to last 5 years under sanctions. They've got mobile phones out that are already 5 years old. They got computers that are already 5 years old, and well, they're still living, but how much longer? And then, of course, there's always the one that just decides to go poof because, well, it lets the magic smoke out. But, my estimate is based on a lot of hazy numbers. In other words, I don't know really. I'm going by some stuff I've heard about reliability levels of electronic gear once it's in service. So, yeah, it could, it may be longer than 5 years, but I'm going to say 5 years because it's a number that makes sense to me based on technology cycles and, well, how long I've seen stuff last myself. To get a really good idea, you'd have to ask somebody like the Canadian Security Intelligence Service, Military Intelligence 6, or the Central Intelligence Agency. They could probably tell you a lot more. Though, of course, considering that they thought Russian troops would be effective, maybe not. It all depends upon the stock of computers and chips that Russia has. I understand that phone manufacturers aren't allowing new activations in Russia right now, so phones are already on the slide, but does Russia have a 5-year supply of military chips? Or a 5-month supply? Or no supply at all? I'm beginning to think it's probably no supply at all, or, well, those Russian tank plants wouldn't have shut down. Now for the extras. Here's a task. You shouldn't believe what anybody says to you on the internet. check with the experts about what I've said. Better yet, hey, get the experts to come here and prove to me I'm wrong. I mean, I know there are experts out there who will quite happily, if they're pointing at something incorrect, and I'm going to point a couple of them to this myself, will happily say, hey, you're being an idiot. For that matter, if you can get David Brin on here to tell me I'm wrong, I'll believe you. I respect David. He knows his stuff. Also, I can't remember where I read it now, but someone reminded me about Hober Mello, a character in Isaac Asimov's Foundation, who won a war by not trading. Yep, it's an excellent story. I recommend it. I think you'll see the parallels between what I'm talking about and the Hober Mello strategy. And from the vast number of comments I've gotten, I've dug up some additional pieces of information. Ukraine is currently a major producer of neon gas. Neon is an element number 10 on the periodic table. Neon is extremely rare in Earth's atmosphere. It is used in science and also in microchip manufacturing. There's been a lot of fear over neon gas supplies, but according to CNBC, Forbes, and Business Insider, the three companies that use ASL machine have 3 to 12 months stock on hand. Note that Ukraine does not supply all of the neon. So, even if one of those companies only has 3 months, the odds are that they're going to be able to continue going for considerable time beyond that. Now, neon is a byproduct of steelmaking. Any country with a large steelmaking industry could, in theory, produce neon. I don't have any idea how long that would take to get up and running. You'd need an expert. ASML and the chip manufacturers became fully aware of the fragility of the supply chain for neon when Russia invaded Crimea and the Donbass in 2014. Since then, ASML claims to have reduced neon consumption by 90% in their machines. I have been told that for years manufacturers routinely vented neon after use, but 2014 changed things and recycling has become more common. Yep, reuse, recycle. I think that this is what ASML's done, is add the recycling system, but my knowledge of the tech is superficial, just enough to know how the basics work. In closing, Russia has really severe problems in this area. It isn't a problem that they can buy their way out of or build their way out of. Inability to obtain microchips is an extinction level event for an advanced technological society. And yeah, if you've seen some of what China's been doing by being very, very non-committal, they're scared of being cut off too. If you go to China, and I've been there, you'll see all the CAD stations are all running Western software. Think about it. Effectively, Russia has no good options, unless they remove Putin, can pull completely out of the Ukraine and pay reparation to Ukraine. And when I say pull fully out of Ukraine, I mean we're talking Crimea and Donbass too. Russia would literally have to walk in sackcloth, piling ashes on their head, crying at this point. There was a pinned tweet on my Twitter profile. It was my immediate thoughts on hearing that Putin had put his foot in his mouth up to his ass. I got some pushback at the time, not so much now. Sorry, there was one other minor thing, and my mind is going blank again, which it always does. So, anyway, if you see this anywhere, the only place I will see the comments are on Twitter or on YouTube. I do not do any other social media. I mean, I have accounts on just about all, but these are the only ones that I check with any regularity, that I have the time to check with any regularity. So, hit me there. If you hit me other places, I won't notice. Please support Ukraine. They are fighting for all of us. Thank you very much. Good evening, and I'll see you soon.